All right, everyone, welcome to our first video here on linear relationships. One of the most foundational parts of algebra is linear relationships. You probably, hopefully, covered it in eighth grade. Um, and so, some of this stuff might be review, some of it might be new, some of it might be a little bit of both. So let's dive in. The most important thing to understand here is that all linear relationships have two parts: a beginning and a rate of change. And that rate of change, for it to be a linear relationship, has to be constant. So, you know, you might think of something like, oh, I start with $10. I start with $10. That would be your beginning or y-intercept, right? We call the beginning the y-intercept here. It's where you begin. So, maybe you begin with $10 and maybe you get $5 every day. And so that would be a linear relationship because it's a constant rate of change. You get the same amount each day. If you get $5 one day, $6 the next day, $7 the day after that, that is not a linear relationship. All right? It has to be the same amount each time. And so some things in the real world are linear relationships. Some things change by the same amount each time. Think about a job. Maybe you get $15 per hour. Every single hour, you get $15. All right. Some things in the world aren't linear relationships, and we can't model them with linear relationships. So, um, it's about understanding where linear relationships can be helpful and where they're not so useful. Looks like I am hitting this twice. It's so important. All linear relationships have a beginning and a constant rate of change. So one other thing I want to show you on a graph. So say we have a graph here. A linear relationship has to be a straight line. Has to be a straight line. If it's not a straight line, it's not changing by the same amount each time. So this is linear. And this would be an example of a nonlinear relationship, maybe something like this. All right. That's not a linear relationship. It's not a straight line. So linear relationships on a graph must be straight. All right. So students will be able to create a linear story, equation, and table when given a real world function graph. All right. And so on your notes, it's going to say story, equation, table. And so just follow along there. I'm going to drag this picture a little bit out of the way of the graph. You don't really need to see me. That's not important. Okay. So we have a graph here, and it's showing banana trees growth. All right. And so on the y-axis, we have the height, and on the x-axis, we have the days. My first step is to look on the y-axis. Wherever it hits the y-axis, that's the y-intercept, or the beginning. And so this is a straight line right here, right? Actually, that should be the first check. Is this a linear relationship? Yes, this is a perfectly straight line right here. If it's linear, we always use the equation y equals mx plus b, all right? And then it's just going to be about filling in the parts of this graph to make, the equation. I'll start with the equation. Now I'll start with the story. All right, what can we learn from this graph? What can we learn from this graph? Well, okay, at 0 days, so at the beginning of the banana tree, it has a height of 8 inches right here at 0 days. All right. So I'm going to write that as part of my story. The tree starts 8 inches tall. That's what I can learn from this graph. The tree starts 8 inches tall, right? Right here. At 0 days, it's 8 inches tall. Now, that's the beginning. The other thing I need to know is the rate of change, the constant rate of change. So how much is it changing by? Well, let's look at our next point on the graph right here. After 1 day, it is now 12 inches tall. So how much did it grow from 8 to 12? It grew 4 inches, right? And it grows 4 inches each time. If I look on the second day, it goes from 12 to 16. So that means that it also grew 4 inches. So what can I learn from this graph? It grows 4 inches per day. All right. That's the story that I can write from this graph. A tree starts 8 inches tall. it grows 4 inches per day. That's the information I can gather from this graph. All right. So that's the story. Again, now let's talk about the equation. An equation, a linear equation, is always y equals mx plus b. Or it can be y equals b plus mx. The order doesn't matter. All right, but for each one, I really need to find what is the slope or the rate of change. We call that m and b. I need to find m and b. We already found them in the story part, right? Where did it begin? B. Where did it begin? 4. So, or sorry, not 4, 8, right here. So I can fill in an 8. That's just the y-intercept. Where do I cross this line right here? Where do I begin? Where do I start? All right. Now to find the slope, we kind of already did it in the last one, but we're going to use this formula always, triangle, which means the change in y over the change in x. How much is y changing each time over how much is x changing each time? So y goes up and down. So to do this, you pick 2 points on the graph. I have these 2 points that I've labeled in pink. How much do I change along the y? From here to here, I go from 8 to 12. How much does that change? Think about it. Well, that's 4. Okay. How much do we change on the x? Right here, this is the x-axis. We go from 0 to 1. That's 4 over 1. Okay. 4 over 1. That's the slope. That's the rate of change. Every day it goes up 4. This can be simplified to just 4 if you want, because 4 divided by 1 is 4. Or you could leave it as this. Both are correct. Okay, so now that I know the m and b, I just plug them into the equation, y equals mx plus b. So I could write it as y equals, instead of writing an m, I know the value of m now. It's 4. I'm going to write a 4. X. And instead of writing a b, I know the value of b is 8. Y equals 4x plus 8. This is the equation that represents this line. But I could do even better. What do I have on the x-axis? I have days. So instead of using an x, I could put a d here, and I could do 4d plus 8. And this is the height on the y-axis. So instead of using y, I could be more specific and use an h. I get h equals 4d plus 8. This equation, let's think about this. We start at 8, and every day we go up by 4. That is equal to the height, all right? So I'm not expecting the people to be masters of this after the first example. So just stay with me here. This is going to be a pretty long video, I think. So, all right, let's clear this out. And now the last thing we need is a table. Tables are pretty easy. We have some relationship here. This is the x-axis, so it should always be xy, right? You could leave it as xy, but if you want to be more specific, you could use days and height. So I always like to go 0, 1, 2, 3. Just say, all right, after 0 days, this is day 0 right here, right? This is day 0. At day 0, what is the height? It's 8. All right? It goes up 4 inches per day. We learned that. So what's day? Now it needs to go up by 4. And you can see that also on the graph. You can do the math, or you can see it on the graph, right? At day 1, it's at 12. Now, again, it goes up 4 inches. So the next day, 12 plus 4 is 16. Again, I can see this on the graph. At day 2, I'm at a height of 16. Day 3, I add 4 again. And at 3 days, the height is 20. Again, you can see this on the graph. Day 3, I'm not doing a very good job of drawing a straight line. We are at 20. All right. And so that is how you take a graph and you turn it into a table, equation, and story. It's all about understanding the parts. All right. It's all about understanding the parts. Different ways we're showing the exact same thing. These are all the same thing, just shown in a different way. All right. Let's do example 2. All right. Here I have the cost of renting a boat, and on the y-axis cost, and on the x-axis hours. Okay, so I'm going to start again with the story. What can I learn from this graph? Well, where does the cost begin? The cost begins here at 20, right? That's the y-intercept right here at 20. So when x is 0, we're at 20. So I'm going to say the beginning is 20. And to find, let's do the equation first this time. I'm kind of all over the place. Let's do the equation first, actually. So y equals mx plus b. All right, and the b, again, is where I begin, at 20. So I'm going to put a 20 right under the b, a positive 20, because it begins at 20. And now remember, to find m, it's a change in y over the change in x. So, all right, this is the y-axis. It goes up and down. Some people learn this as rise over run, right? How much? I'm going to pick a point. It doesn't matter which point I pick. I'm going to pick the next one. How much does the y change? You're good. I'm just making a video. How much does the y change from here to here? We go from 20 to 30. How much did we change? Well, we changed by 10, right? We went up by 10. How much did we change on the x from here to here? We only went over our run. There's only 1. So this is the slope. I can simplify 10 over 1 to just 10 if I want to, all right? So now I have m and I have b. Those are the only two parts you need for a linear function, the rate of change and the y-intercept. I can rewrite this as y equals mx plus b. All right. Again, I started to do this up here, but let me just move it down here where I have more room. Where there's a b, I'm filling in a 20. Where there's an m, I'm filling in a 10. So I get y equals 10x plus 20. But if I want to be more specific, I can also fill in the proper x and the proper y. All right. So x is really hours. So I could write this as 10 each representing hours. And the cost, C. So what this means is the cost of renting the boat is equal to 10 times the amount of hours plus 20. That's what this equation means. If I said, hey, how much does it cost to rent it for 4 hours? You'd plug in a 4 to h, you do 10 times 4 plus 20. 10 times 4 is 40 plus 20, and you see right here is 60. All right, so this equation helps show the relationship between these two variables. If you know how many hours there are, you can calculate the cost. If you know what the cost is, you can say how many hours they took the boat. So this should make the story pretty easy now. I'm going to clear this out. I don't have enough space. The story is pretty easy, right? We begin at 20, right? So the starting cost is $20. So before you even start, just to get on the boat, it costs $20. After that, you pay per hour. It's $10 per hour. So it cost $10 per hour. All right. So this story also has the two parts of a linear function. It has the beginning and the constant rate of change right here. Okay. That's the story. Last thing is the table, right? X and Y, but really I could call this H and C for hours and costs. So bam, we can just do 0, 1, 2, 3. If I wanted to plug in, all right, what does it cost if you rent the boat for 0 hours? You just sit down in the boat and you don't do anything else. Well, it costs $20, right? Just to sit down in that boat. Now it goes up $10 per hour. So 20, I do 1 hour. I should add 10. It's 30. Again, you can see this on the graph. 1 hour costs $30. 1 hour costs $30. I add 10 again, it's 40. Again, I can see it on the graph. 2 hours costs $40. Add 10 again, it's 50. All right, and so here I have my table. These two things show the exact same relationship. They show the relationship between how many hours you rent the boat and what the cost is. They just show it in a different way. You can get the same information from here. They're just shown in different ways. You have to be able to read linear functions in all the 4 ways: stories, equations, tables, and graphs. All right, this is a lot to throw at you, but I still want you to go ahead and try it. So go ahead and pause and see how much you can get done. All right, go ahead and pause. All right, hopefully you just finished. Since it's a you do, I'm going to go over it a little bit quicker. It doesn't matter what you started with. I'll start with the equation this time. And so again, to start with the equation, I need to find the two parts, the rate of change or slope. Those are the same thing. You'll hear me use those words interchangeably. And B, I'm going to start with B. That's where I begin. Where does this graph begin? Well, it begins right at 5. Okay. Hopefully you're catching on to that. These graphs are a little weird because it really should be hitting right here, but they put 0 off here. So we're going to ignore that a little bit. Okay. Hopefully the other graphs are better formatted. Now I want to know the rate of change. So how much do I change from here to here? To figure out the rate of change, we do the change in y over the change in x. All right, the change in y over the change in x. So how much do we change on the y? I go up 1. Ooh. All right, whatever. We'll just count like that. 1, 2, right? I go from 5 to 7. 5 to 7. So my change in y is 2. How much do we change on the x? Well, we just go over 1. So our slope, or rate of change, is 2 over 1. If I want to simplify that to 2, I can. So I get m is 2, b is 5. I need to use the equation y equals mx plus b. And now let's plug in. Y equals, what am I plugging in for m? I know it's 2. X plus, what am I plugging in for b? I know it's 5. I get y equals 2x plus 5. That graphs this line right here. This line right here. That y equals 2x plus 5. But I can do a little better. I can also plug in for x. The x in this scenario is days, and the y is savings. And so I could say something like, for the y, I could put an s. For the days, I could put a d. All right. So what's the relationship between how many days in your savings? We can show that relationship as the savings is equal to 2 days, 2 times the amount of days plus 5. All right. All right. That's the equation. Let's do the story. We kind of already do the story naturally. Where do your savings begin? You began with, it looks like, $5. So let's just say you have, you could use you or I, it doesn't matter, make up a person. You have $5. Every day, how much does it change by? Well, it's going up by 2, right? On day 2, you have $7. Or on day 1, you have $7. On day 2, you have $9. So you get $2 per day. All right, so there we have a nice, simple story. Again, this and this graph and this story, they show the exact same thing, just in a different way. You get the same information from both. What two pieces of information are we always looking for? Where you start and how much you're changing by, your rate of change. All right. Last, we got to do the table. Okay, X and Y. And if I want to say X is days and Y is savings, I can. I'll just fill these in as 0, 1, 2, 3. Now, at 0 days, how much savings do you have? You have $5. You start with $5. After you get $2 per day, so you're going up 2 each time. We can easily fill these in just by counting it by 2. 7, 9, 11. Done. Just so you can see it on the graph as well, because again, they're showing the same thing differently. Let's look. After 1 day, $7. After 2 days, $9. Now the third day isn't on the graph. All right. All right. Let's try one more you do. Go ahead, pause, try it on your own, and then we'll go over it. Okay. Let's start with the equation. I'm going to go really quickly through this. We began at y equals mx plus b. M equals b equals. We begin at 50. This is where it gets a little bit complicated. Might have missed this. Our change in y over our change in x. Here's the difference with this change in y from here to here. We went from 50 to 45. So what happened? We went down 5. I'm really going to show that as a negative 5. Right? If we're going down, it needs to be negative. I went from 50 to 45. That's down 5. The y should be negative. We went over 1 on the x, and we get negative 5 over 1, or negative 5 is our m. Okay? Now that I have my m and b, I can plug these into the equation. Y equals mx plus b. Y equals negative 5x plus 50. Plug in days for x and savings again for y. So I get s equals negative 5d plus 50. All right. There's the equation. Clear this out. Now let's do the story. What's happening here? Let's just give this a name. Let's say Kyle. This is about Kyle. All right. Well, how much money did Kyle start with? At 0 days, he has $50. Kyle has $50. What happens every day? He's going down 5, right? Down 5, down 5, down 5. So he loses $5 per day. Kyle has $50, he loses $5 per day. All right, that's what's happening here. Let me clear this out one more time. Let's go over the table. X, Y, days, savings, 0, 1, 2, 3. After 0 days, we know that's where Kyle began. He has $50. He goes down $5 a day. So all I have to do, count down by 5s. 45, 40, 30. All right, you can see the same thing on the table. All right, this was a pretty quick video for a pretty tough lesson. So I imagine you'll need more help than just the video. If you don't, great. But if you do need more help, that's what Coach Class is for.